What is the greatest common factor of 630 and 1050? We'll begin this problem by reviewing the prime factors method of calculating greatest common factors, and then we'll follow up with a quick and dirty approach that would help solve the problem on a test in a more timely manner. So let's begin. We want to do a prime factorization of 630, which means we want to divide by prime numbers until we get to the point where we are down to only prime numbers and cannot divide that number anymore. So in the case of 630, well, that's an even number, so I know I can divide that by 2, and half of 630 is 315, and 315 ends in a 5, so I know right away it must be divisible by 5, also a prime number, and 5 goes into 120 times, so into 300 it goes 60 times, plus 3 more times into 15, so that's 63 times 5 equals 315. And 63, we know, is 7 times 9. We're lastly down to 9, and that is just 3 times 3. So my prime factors for 630 are 2 times 5 times 7 times 3 times 3. Let's review prime factorization of 1050. We know 1050 is also divisible by 2, and 2 times 525 equals 1050. And again, 525 ends in a 5, so we know that's divisible by 5. In fact, that's 105s plus 5 more that go into 25. 5 times 105. And that again is divisible by 5. 21 times 5 equals 105. And we know 21 is 3 times 7, which are 2 primes in themselves. So we now know the prime factors of 1050 are 2 times 3 times 5 times 5 times 7. Now, in order to determine the greatest common factor, we want to include all the common prime factors, and the product of those numbers will be the greatest common factor. Which figures are in common? 2, we have 1 5 in common, we have 1 3 in common, and 7. So our greatest common factor equals 2 times 3 times 5 times 7. 2 times 3 is 6, 6 times 5 is 30, 30 times 7 equals 210. So our greatest common factor is 210, and that is our solution from the prime factors method. Learning how to do a prime factorization will be useful for least common multiples and in many areas of the test. You will see it repeatedly. It is worth practicing and getting very comfortable doing it. Okay, I loved climbing trees as a boy, but I'm not so sure I would say I love prime factor trees. I think we should take a few moments and teach these young students a faster way to solve this problem. Don't you think, Einstein? Okay, let's get to it. The fastest and easiest way to solve this problem does not include prime factorizations. Since we're looking for the greatest common factor, we can start with the greatest answer. The greatest answer shown is 240, then 225 and 210. We'll begin with 240, and we want to check, is it a factor of each number? Therefore, is it a common factor? 240 times 2 is 480. 240 times 3 is 720. So 240 does not quite divide evenly into 630. So 240 is not a factor of 630 and cannot be a common factor, let alone a greatest common factor. How about 225? 225 times 3 is 675. That's too high for 630. How about times 2? No, that's 450. So between that, there's no other whole number multiple, and 225 also does not divide evenly into 630. It is not a factor. How about our next answer lower? 210. 210 times 3 is 630. That works. Times 3 equals 630. Okay, let's see if it's also a factor of 1050. Looks like it would be about 5 times. 5 times 210 equals 1000, plus 10 times 5 is 50. It is 1050. 210 is the greatest of the answers available, and it is a common factor to both 630 and 1050. That is our greatest common factor. We were able to find it very quickly by leveraging the answers provided in the question. If you've ever seen a test where there's always one kid for an hour test, gets up, walks up to the front and hands his paper in after 30 minutes, and he knows he's right on every problem, getting 100%, well, chances are he's utilizing a lot of tips and faster methodologies for solving problems, like this one. I know, because I used to be that annoying kid myself. I want to share some of those tips and methodologies with you guys.